Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So today we're doing another video here. Today it is on general chemistry for nuclear chemistry. All right, so here we go. This is a worksheet I have designed here, and you're watching the Crazy Hat Chemist. So nuclear chemistry, here we go. All right, so what you need here today is a calculator, a periodic table, and this worksheet, and that's how we're going to do this. So we're going to do each one of these problems here, and we're going to be successful, and I know you will. So here we go. So what we're going to do is write the equations for the following. We're going to have uranium-238 undergoes alpha decay. All right, so how do we do this? Let's get moving. So the first thing that we need to do is we need to find uranium on the periodic table. Okay, it should be a mass very closely approximating 238, but it might not necessarily be 238. So what we're going to do is look on our periodic table, and what do we find? Uranium, we have a mass of about 238. It's not exactly equal to 238, but it's pretty darn close. Okay, and that would be uranium. That's U, and that's element number 92. Okay, so that's going to be critical in our ability to solve this problem. So what we're going to do is we're going to first write out the formula for uranium in the AXZ or standard nuclear notation. So that is A, X, and Z. Okay, the A is the atomic mass that is equal to the sum of the protons and the neutrons. And Z is the atomic number, which is equal to the number of protons. And this is standard nuclear notation. Um, this X here is equal to the symbol of the element. So this whole thing right here is standard nuclear notation. Okay, so standard nuclear notation, that is exactly what we want. And we're going to be using standard nuclear notation throughout this entire process here. So we just found uranium on our periodic table because we looked up 238 for the atomic mass. And so we're going to write 238. That is replacing A. Z on our periodic table was clearly, hopefully, 92 for uranium. So we're going to use that number. That's 92, and the symbol is AU. So this is how we're going to work this here. Now, all of these reactions are decomposition reactions. So a decomposition reaction, it starts off with one reactant and you get two or more products. In all of these, we're going to get only two products with one reactant. So it says that it undergoes alpha decay. So alpha decay is you need to be able to write the numeric values in the AXZ format and the alpha symbol. So alpha decay is a 4, a 2, and it's an alpha symbol. That alpha symbol kind of looks like a fish swimming horizontally, so that might be one way to do this here. Then it's going to be plus. Now, what I'm looking for is I'm going to write this in pencil so that I can erase this. This is A, X, Z. I need to solve for the A, I need to solve for the Z, and then I will have my answer. So what we're going to do is do this off to the side just a little bit. A little bit of arithmetic problem is what we're looking for here. And this is how we're going to do this. We're going to take this top portion here, which is our numerator portion, and we're going to take our bottom portion, our denominator portion. We're going to do them two separate parts. And I'm going to do this here in the 238 is equal to, so 238 is equal to 4 plus A, 4 plus A. So what we're doing is we're really actually mathematically solving for A. So you're going to subtract 4 on both sides, and then what do you get? 234. So A is going to be 234. So what we're going to do is we're going to get an eraser. We're going to erase the A and that will allow me to replace that A with 234. Now you should actually check your work to make sure that this works out okay, and that's 234 plus 4. Does that equal 238? Yes, it does. So we're good right there. All right, so that was the numerator portion. The denominator portion is exactly the same mathematically, except different numbers. It's going to be 92 is equal to 2 plus what number? And that number is going to be z. So 92 is equal to 2 plus z. So what we're doing is we're solving for z. We're going to subtract 2 on both sides, and we're going to solve for z. So I'm going to erase the z once we solve for it, and that z will be 90 in this case. So that will be 90. Okay. Now what we're going to do is we're going to erase the x, and the x is going to be equal to the atomic number. So the atomic number, if you recall, the atomic number is the number of protons, and that identifies the element. If you have any doubt about this, you need to be looking at my atomic structure lecture series. Okay. And so we're going to look up element number 90, and we're going to find 90 in our periodic table. Let's highlight that. That is element number 90. It is TH, and that's thorium. So I'm going to write the symbol capital T, lowercase h, and that will be thorium, TH. All right, fantastic. So this is the equation here for this uranium-238 undergoes alpha decay. All right, so now we're going to continue on. We're going to move on to problem number 2. So here we go. It says thorium-234 undergoes beta decay. And so thorium is right there. That's 232. That's close to 234, but we're going to use 234 because that's what the problem says. And it's TH, and it's element number 90. Okay, so I'm going to use this in a different color pen. So I'm going to alternate color pens so that we can see this. This is TH. That's 234. We just figured out that was element number 90. It undergoes now what's called beta decay. So you do absolutely need to know what beta decay is and what the numbers are. The numbers are 0, -1. The symbol is like a B scripted with a tail on it. And we're going to be doing the same thing mathematically that we did over here. And that's AXZ. We're solving for AXZ. 234 is equal to 0 plus what number? That would be 234, of course. And then 90 is equal to -1 plus what number? That's the Z, and that's going to be 91. All right, so now I need to look up 91 on our periodic table, and we are going to find that right here. That is element number 91, and that is protactinium, and that is Pa. So I'm going to write here Pa just like that. Perfect. All right, cool. All right, we're going to carry on. We're going to keep on going here. Our next one is uranium-234 undergoes alpha decay. So again, another alpha decay. It's uranium. It's 234. We're using standard nuclear notation. We already looked on our periodic table, and we found uranium. Uranium is right there. It's element number 92, so that shouldn't be a problem, hopefully. So that is element number 92 equals. And it says it undergoes alpha decay, so you have to know 4 and 2 and the little fish swimming horizontally to the left. Plus the A, so that's 234 is equal to 4 plus A. I'm going to solve for A, just like what we did right over here. I'm going to subtract 4 on both sides, so that's going to be 230. And then it's 92 is equal to 2 plus Z. I'm going to subtract 2 on both sides. So that will be 90. And now I'm going to look on my periodic table, and I'm going to find element number 90. And we've actually already done element number 90. That's 90, and that's TH for thorium. So I'm going to have TH for thorium just like that. Perfect. All right. We're going to keep on scrolling down. We're going to do the next one. It's radon-222 undergoes alpha decay. So I'm going to find radon on our periodic table. It will be close to 222. It might not be exactly 222, but it will be close to it. So where'd we go? Here we go. There it is. Radon 222. It's element number 86. So 222 radon. That's Rn. Rn, like if you were a nurse, and that's 222. That's element number 86. And this is going to undergo what's called alpha decay. So that's a 4 at 2. That's the little fish there. Plus, so it's 222 is equal to 4 plus A. I'm going to subtract 4 on both sides. And I should get 218. And then it's 86 is equal to 2 plus what number? I'm going to subtract 2 on both sides. So that is 80. What would that be? 84. 84. And so I'm going to look up atomic number 84 on our periodic table. I'm going to find element number 84. And where is 84? Here we go. Let's find 84 on our periodic table. There is element number 84. That is PO for polonium. So polonium, here we go. PO for polonium. Perfect. All right, let's do our next one here. Our next one is polonium 218 undergoes alpha decay. So I'm going to have polonium 218. We just figured out what polonium was. That's 218. That's 84. And that's PO. It's going to undergo alpha decay. That's a 4. That's a 2. That's like the fish. And it's 218 is equal to 4 plus what number? I'm going to subtract 4 on both sides. Excuse me, and that will give me 214. Again, you should be checking your work. So it's really 214 plus 4. Does that equal 218? Yes, it does. Okay. 84 is equal to 2 plus z, and I'm going to subtract 2 on both sides. I'm going to get 82. And again, you should be checking your work. That's 82 plus 2. Does that equal 84? Most certainly it does. I'm going to look up 82 on our periodic table, and that is the most important element, and that is for PB, that is for lead. Okay, so it's element number 82, and it is PB, that's for lead. Perfecto. All right, we're going to keep on going here. Our next problem here is going to be lead 214 undergoes beta decay. So we have 214, we have 82 for the lead, that's PB. It's going to undergo beta decay. The numbers are 0 and -1. It's a beta symbol. And then plus, so 214 is equal to 0 plus what number? I'm going to subtract 0 on both sides. I get 214. 82 is equal to -1 plus z, and I'm going to add 1 to both sides. That will be 83. Now I'm going to look on my periodic table. I'm going to find element number 83. Where is 83? Here is element number 83. It's Bi for it's none of your what? It's none of your business. That's correct, folks. So that is Bi. All right. Perfect. Next one is bismuth 214 undergoes a gamma decay. So I got 214, I got 83, and I got Bi for bismuth. There's an arrow. Okay, and now I got gamma decay. Gamma decay, you need to know the numbers, have memorized them. They're a 0 and a 0. And imagine it's like that fish that's swimming down. Plus, this is the easiest one to do mathematically, hopefully, obviously, and that would be 214 is equal to 0 plus what number? That's 214. 83 is equal to 0 plus what number? That's 83. You don't need to look this up on the periodic table because it is bismuth. And then I'm going to put a little asterisk here, and the asterisk means that this element of this particular isotope of this element is lower in energy than this one. By releasing that gamma particle, it lowered this energy to have a lower energy with this one here on the product side. That's really what's happening. Okay. All right. So I'm going to continue on. I got polonium 214 undergoes alpha decay. So I'm going to have to find element 24. Well, sorry, I'm going to have to find polonium, which has a mass approximating that of 214. So we had actually used polonium before. There's 209, but it is 84 and PO. So I'm going to use that. All right. So it is PO. It's element number 84. And it has a mass of 214. It's going to undergo alpha decay. Those numbers are 4 and 2. Remember, it's the horizontal fish. So it's 214 is equal to 4 plus what number? Subtract 4 on both sides, I get 210. Then it's 84 is equal to 2 plus what number? I'm going to subtract 2 on both sides, I'm going to get 82. I'm going to look up 82 on our periodic table. I'm going to find that element. It's 82 is Pb for lead. This is Pb. Perfect. All right. The next one here is number 9, and that's lead 210 undergoes beta decay. All right, so we just looked up lead just a moment ago. That's 210 and that's 82. And it's going to undergo beta decay. The numbers are 0 and -1. That's the beta symbol. Remember, it's a scripted B with a little tail on it. And so it's 210 is equal to 0 plus what number? That's 210. 82 is equal to -1 plus z. I'm going to add 1 to both sides. This will be 83. So I'm going to look up 83 on our periodic table, and we've most certainly done this already before. And that element 83 is Bi, like it's none of your business. All right, perfect. All right. The next one here is problem number 10. It says bismuth 210 undergoes beta decay. So I have 210, it's bismuth, and that's 83, and that's Bi. It undergoes what's called beta decay. So that is 0, -1, and that beta symbol plus. And that's going to be 210 is equal to 0 plus what number? That's actually 210 again. 83 is equal to -1 plus z, and we're going to add 1 to both sides. That's going to be 84. I'm going to look up 84 on our periodic table. 84 is right. Where is it? It's right there. That's polonium again, and that's PO. Awesome. I'm going to scroll this on up here for just a little bit here, and we're going to do polonium 210 undergoes alpha decay. So we have polonium, that's 210, and that's element 84. It's going to undergo alpha decay. That's a 4 and a 2. That's alpha decay for that alpha symbol. So now I have 210 is equal to 4 plus what number? I'm going to subtract 4 on both sides, and I'm going to get 206. And then 84 is equal to 2 plus what number? I'm going to subtract 2 on both sides. That will be 82. And then what we're going to do is we're going to look on our periodic table, and we're going to find element number 82, and that's Pb, and that is for lead, Pb. All right, fantastic. That gives you a great summary of this. This is actually part of each one of these is part of a decay series, and that's why we actually did this right here. All right. Now what we're going to do is we're going to do problem number 12 and problem number 13. Okay, so I'm going to fold this piece of paper over here. I'm going to scroll this on up here, and we're going to do problem number 12 first. Excuse me. So problem number 12, it says uranium-238 undergoes a series of alpha, alpha, beta, gamma decay. Write the equation and identify the product. So uranium-238, we're going to start off with that. We need to figure out what the atomic number for uranium is. And we have figured that out before, and that is element number 92. That's 92, just like that. It undergoes alpha decay, which is 4, 2, there's that, plus alpha decay, 4, 2, alpha decay, plus beta decay, that's 0, -1, that's beta decay, plus gamma decay, that's 0, 0, plus alpha decay again, 4 and 2 for an alpha, and then a beta decay, and that is 0, -1 for a beta decay. And then I think finally we have a gamma decay plus 0, 0 for gamma decay. And let's just verify that this is all what we've got here. So we have this alpha, that alpha. We have this alpha, we have this alpha. We have this beta, beta. We have a gamma, we have a gamma, we have an alpha, we have an alpha, we have a beta, we have a beta, we have a gamma, we have a gamma. All right, perfect. So now what we're going to do is we are going to sum up all the numerator numbers. So that's 4 plus 4 plus 0 plus 0 plus 4 There is a plus sign here in between these. I apologize. There we go. Plus 0, plus 0. So that's 4, 8, 12. So we're going to take 238 and we're going to subtract 12 from that. What do we get? 226. So I'm going to write this in another color here. That's 226. All right. And then we're going to take 2 plus 2. That's 4 minus 1. That's 3 plus 2. And that is going to be 5 minus 1. And that's going to be 4. So it's 92 minus that 4. That's going to be 88. Now what we're going to do is we're going to look on our periodic table and we're going to find element number 88. And where is 88? 88 is right here at radium, and that's Ra for element number 88. So this is Ra, just like that. So this is a series of decays, and all you have to do is add them up. It's very similar to what we were doing. It's just a series of decays. All right, perfect. Now we're going to do the next one, which is also another series of decays. So let's cover that one also. All right, so we're going to fold this piece of paper over again. And this was problem number 12. So I'm going to write that down here like that. That one's problem number 12. We're going to draw a line. And we're going to do problem number 13. Problem number 13 and problem number 12 are very similar in how we do them. It says platinum 198. So we're going to find platinum on our periodic table. It's actually right next to gold. Platinum right there. It's one of my favorite elements because my wedding ring is platinum. Okay, so PT is element number 78, right? So we have 198. That's PT. That's 78. So that's platinum. So what we're going to do is we're going to undergo an alpha decay. That's 4 and 2 alpha plus. So I'm going to cross that one out. A beta decay. That's 0, -1. That's beta decay. Cross that out. Plus gamma decay. That's 0, 0. Gamma decay. Cross that out. Alpha decay. Plus 4 and 2. Alpha decay, cross that out. The last one is beta decay, plus 0, -1, beta decay, cross that out. And it looks like I have all of them. All right, so we've checked those off. Now we're going to have plus, and we're going to have our answer. So it's 4 plus 0 plus 0 plus 4 plus 0. That's a total of 8. So I'm going to have 198 minus 8. That is 190. All right, then it's 2 plus -1 plus 0 plus 2 plus -1. That is a total of 2. So I'm going to subtract 2 on both sides. That will be 76. Now I'm going to look on my periodic table and I'm going to find element number 76. Element number 76 is right there, and that's osmium. Osmium, that's OS. It's capital O and capital F. Perfect, just like me. I think that looks beautiful. You guys are doing a great job. All right, fantastic. So make sure that you make a note of this here. And what we're going to do is we're going to go on to the next problem, which is problem number 14. And then we'll just cruise on from there. So here we go. We're going to move this piece of paper here in just a second so that we can see problem number 14. But I'm just going to leave this up here for just a little bit. Hey, by the way, you are watching the Crazy Hat Chemist, and if you are learning something here, I would greatly appreciate you giving me a thumbs up on this video, and also please give me a like and subscribe to my YouTube channel. I would greatly appreciate that. Thank you very much. All right, let's go on to problem number 14. Okay, so after that short little brief advertisement, I'm going to fold this on out and we're going to hammer out the rest of these problems here. So here we go. Let's scroll this up so that we can see all the rest of these. And perfecto. All right, so what do we got here? All right, so it says here for our next set of problems, it says when hydrogen 1 atom and when a hydrogen 1 atom and a hydrogen 3 atom combine to form helium 4, this is an example of nuclear fusion. It's one of the possibilities of which the sun does, by the way. The nuclear reactions that take place in nuclear reactors of power plants are fission or fusion reactions, and that is, they are fission reactions. They are splitting reactions. They are not fusion combining reactions. Nuclear fusion is what takes place in the sun. True or false? That is most certainly true. Atomic bombs are uncontrolled chain reactions of nuclear fission. That's splitting. That is most certainly true, not false. We'll cross out the false. And then it says how much uranium-238 will remain of a 50-gram sample after 5 half-lives. All right, so what we need to do is scroll this worksheet on up so that we see more of this bottom section here so that we have more space to write out the rest of these problems here. All right, so we're going to do problems 18, 19, and 20. Here we go. So here is problem number 18. I'm going to do that in this space. Okay. All right. It says how much uranium-238 will remain of a 50-gram sample after 5 half-lives. So this is half-life problems. So we're going to do a half-life problem here. So it says we have 50 grams. So we're going to have 50 grams, and we're going to set up like a little T-chart. Okay. That's what we're going to do. This is the amount, and this is the number of half-lives. Okay. And so this is 0 half-lives because this is what we start off with. All right. So that's what we have in this problem, 50 grams. And it doesn't matter that it's uranium-238. That has no relative to the amount of math that we do or the type of math that we're doing for this particular problem. It says that we have to reach a total of 5 half-lives. So we're going to go 0, 1, 2, 3, 4, and then 5. So that's as far as our table is going to go. So we're going to take our table all the way down to 5 half-lives. Once we reach 5 half-lives, it is going to be this number in this rectangular box that we are most certainly interested in. All right. So what we did from each one of these is we just added 1 in each column, and that's how we got the numbers here. So we just added 1 in each column. Okay, now what we're going to do is on this one, we're going to divide by 2. So we're going to take 50, divide by 2, and we're going to get 25 grams. Then we're going to take that, and that corresponds to 1 half-life. So after 1 half-life, how much remains? 25 grams. We're going to take this 25 grams, we're going to divide by 2, and we're going to get 12.5 grams. That's how much remains after 2 half-lives. Okay, and then we're going to take this 12.5, we're going to divide that by 2, and we're going to get 6.25 grams. That's how much remains after 3 half-lives. We're going to take this number and divide it by 2, and that will equal 3.125 grams, and that's how much remains after 4 half-lives. And then we're going to take that and then divide by 2, and we're going to get our answer that we're looking for, and that is 1.5625 grams remains at the end of 5 half-lives. All right, that's perfect. Hey, by the way, just a quick little advertisement break. You are watching The Crazy Hat Chemist, and I hope you're actually learning something. If you are learning something, can you please give me a like and subscribe? All right, we're going to draw a line right here, and we're going to do problem number 19. Okay, problem number 19. So 19 and 18 are very similar, as well as 20. It's just the number of half-lives and what we're starting off with. So what we're going to do is we're going to do a little T-chart like what we did on the past one. And it says how much carbon-14 will remain of a 10-gram sample after 6 half-lives. So this is amount and number half-lives. Okay, so we're going to start out at 0 half-lives, which is the original amount, which is 10 grams. So we're going to go 0, 1, 2, 3, 4, 5, and then finally 6. How did I come up with these numbers? I added 1 each and every time. That's how I came up with these. I just added 1, added 1, added 1, and I want to get to 6 half-lives because that's what the problem says is 6 half-lives. And then what do I do to this column? I'm going to divide by 2. So divide by 2. I'm going to divide by 2 until I get to 6 half-lives. And then this number right here will be my answer. So 10 divided by 2 is 5. And then I'm going to take that and then divide by 2 again. Divide by 2, and I get 2.5. And then so that's at 2 half-lives, 2.5 grams remain. I'm going to divide by 2 again, and I'm going to get 1.25 grams. That's at 3 half-lives. I'm going to divide that by 2 again, and I'm going to get 0.625 grams. I'm getting closer. I'm going to divide this by 2, and I'm going to get 0.3125 grams, and that's at 5 half-lives. And then I'm going to divide that by 2, and I am actually going to get my answer that I'm looking for, and that will be 0.15625 grams. And so how much remains at the end of 6 half-lives? If your sample begins with 10 grams, I will have 0.15625 grams remaining. That's it. Okay, now what we're going to do is we are going to do the very, very last problem here, which is problem number 20. Problem number 20, okay? And we're going to do a little t-chart like what we were doing before here. It's very similar. It says amount and number of half lives. Lives, there we go. Okay, so what are we starting off with? We are starting off with a 20-gram sample. 20-gram sample, that's what we're starting off with, and that's at 0 half-lives. We want to reach 8 half-lives. And it says how much of a hydrogen-3 sample will remain of a 20-gram sample after 8 half-lives. So we're going to have to move this all the way down to 8 half-lives. That will be 1, 2, 3, 4, 5, 6, 7, and finally 8. And once we get this number right over here with the 8, we will be looking for this number in that little section right there. So again, how did we get each of these numbers? We added 1 each and every time. Okay, add 1, add 1, add 1, add 1, okay, and add 1. And that's how we got that. For each of these in this column, we're going to divide by 2. Okay. So we're starting off with 20. We're going to divide by 2, and we get 10-gram sample. That's how much remains at 1 half-life. We're going to divide that by 2, and that will be 5 grams. So we have 5 grams at the end of 2 half-lives. We're going to take that and divide by 2. We're going to get 2.5 grams at the end of 3 half-lives. And then we're going to divide by 2 for every one of these. Divide by 2 again, we get 1.25 grams at 4 half-lives. Divide by 2, we get 0.625 grams at 5 half-lives. Divide by 2, we get 0.3125 grams at the end of 6 half-lives. Divide by 2, we get 0.15625 grams at the end of 7 half-lives. And we are going to divide by 2 one more time. Divide by 2 one more time, and we're going to get our final answer, which is 0.078125 grams. And that is our answer. So at the end of 8 half-lives, we have 0.078125 gram sample yet remaining. That's perfect. All right. I am the Crazy Hat Chemist. I hope you enjoyed this video, and I hope you have a fantastic day. Let me zoom on out so that you can see the full potential or the full worksheet here of all of these, just in case you needed a little summary of everything. So not quite. We're getting really close. There we go. I think we're there. All right, so this is the entire worksheet right here that you see. the entire worksheet. All the problems are right there. Should take a picture of that. Make sure that you know how to do each of these problems. You should probably watch my lecture video so that you can follow along with that as well. I hope you have a fantastic day, and I'm going to see you next time for more cool chemistry problems. And see you then. Love you a lot. Talk to you later. Bye for now.